So it's definitely recording this time, so we'll see what happens. I think if I keep moving, it won't turn off. So I think I have to keep active and make sure that it's focusing on me here. And I don't know if Cesar is going to join us or not. I don't know what I'm going to get on this thing. I was trying to charge it up. It does seem a red light came on. Okay, so for the fraud case, the first thing was supposed to be a relatively simple just use a fit y by x to remind ourselves of how to do that and maybe to see some information that would help us to emphasize the fact that we can use several different techniques on the same data. But I think if we go to the column viewer to begin with, and we take a look at all the columns here and then say show summary. So the first thing I'm going to notice about the credit score. So if we go down to credit score, we see that it goes to 108 values missing, and it goes from minimum of 300 up to maximum of 9999. So do you remember when we said what 9999 was often used for?
Just to put a value in?
Yeah, just to put any old value in. So chances are, if we wanted to edit this properly, what we should do is we should recode 9999 to be missing. And then what about 300? What's the lowest credit score possible?
350?
Yeah, so I think it's something approximately 350. So again, we might say that those were erroneous pieces of data, and so we might want to go ahead and just quickly recode those to get rid of those. So to do that, I would right-click on age group, and I would say go to utilities, and I would say recode. And oops, I got the wrong one here. So I need to go to credit score. It's awfully hard to do this. Credit score, utilities, recode, and then I would. What do you think I should do? I should get rid of all the ones that were up to 350.
Is 350 really the lowest?
I don't know. Actually, that's too much work. I think I'm not going to bother with that right now. That's kind of a waste of time. But anyway, I will go ahead and recode the 9999. So let's do that one. Back down here, 9999. I'll recode that one down to that and say no and say done and say in place. All right. So now we go to we have to get rid of the outlier also. So the outlier on the claim amount, I can just basically easily sort these before I've done anything else, descending order. Oh, I already have an analysis going. All right, record ID 16699. So I'll just go down to 16699 here. Quick way to do this, 16699. And there we go, and just Control E to exclude. All right, so I can say analyze fit y by x, and then I can just put the outcome as the x factor, and I can put the attorney. It was whether or not they used an attorney, right? That's also, I wanted to do that, and then the claim amount. So I was going to look at the claim amount based on whether or not they had attorney or based on whether or not they had fraud, and I can just click on OK, and it's got my two analyses right there. I hit Control key. Means ANOVA, and I see yes indeed that for the claim amount for cases that were not fraud minus fraud, the fraud cases, actually I think I misstated this to somebody back here. I said the fraud cases were higher claim accounts, but this is fraud minus not fraud, and so I mean not fraud minus fraud is minus 89, which means fraud is $89 higher, right? Because it's minus 89 here for not fraud to fraud. And then it's a statistically significant difference. So that might give us an idea that fraud cases are costing us more. And then on the other side here on the claim amount by attorney, it looks like if they're using attorney, in this case, we also have a statistically significant difference of $160, but in this case it is in fact no attorney. The claims are higher. So that's kind of a conundrum. Why would that be? We don't really know. So the point was to get you thinking when you looked at that data to get started. All right, so the next thing we needed to do was to make a validation column. So we went to columns. We went to modeling utilities, make validation column. We changed this to 0.6 and 0.2 and 0.2. And we made it a stratified random sample. See, there I hit the wrong thing, so I didn't think it was stratified random. So I'm going to delete it and I'm going to do it again. So column, modeling utilities, make validation column. 0.6, 0.2, 2.2, stratified random. And then stratified on outcome, you say OK. A way or none. Why have I got ref on that? That's interesting. All right. I created some new columns during lunch, so obviously I didn't do it quite right. All right, I'm going to say analyze, I'm going to say modeling, I'm going to say partition, and then at this point I'm going to put outcome in the Y. I'm going to put everything else in the X that Charles put in, credit score, newly insured, total monthly income. Leave out all the rest of those columns there and click on OK. All right, so, and then I'm going to click on color points. I forgot to put in the validation column. So go back to analyze, modeling, partition, getting off to a slow start here after lunch. And the validation column goes in the validation box. I hit OK, color points, and then display options and show split count. Okay, now I'm ready to hit go. So any questions up till this point? All right, so I think most people got to this point, or everybody got to this point. You hit go. When you hit go, you find that how many splits did it do? It did 9 splits in this case. You can see that the R-squareds of all 3 sets are relatively close to each other, 0.19, 0.21, 0.22. So again, I would say that that's close enough that you don't have to worry about the model being overfitted. And then if I, wait, oh, that was nothing, okay. And then, is that a phone or something? And then I'm going to say show fit details, and we're going to see that we've got 0.07, 0.08, and 0.07 for our misclassification rates. So they're close enough that we can conclude the model is not overfitted. And then when we come back up here and we say show the column contributions, we see the most important thing is credit score, the next important thing is attorney, then the total monthly income, then gender. And so if we go to the leaf report, we can try to ponder the meaning. And so the most important rule was probably you got something like this, credit score 345 or missing, any attorney or attorney Smith or something like that. So how did you interpret the whole attorney issue then?
Can I ask just one question right there? When I got to that point, it didn't give me the direction that I did. It just had ascending. I could click that box. Am I going to send it the other direction without clicking the box?
I don't know. This does not appear to be. Don't assume that these are sorted in general, that these are going to come to you sorted.
Oh, okay.
So what this, it might be just a happen of chance that this looks like it was sorted. So make sure you right-click, say sort by column, and then say whichever one you want to see. And then if you say fraud and don't click on ascending, then it's going to sort it so that you see the one that is most likely to fraud. So that's credit score greater than equal to 345 or missing, total monthly income less than 10,295, and attorney lawyer team. I read it wrong just a moment ago. Because why? I didn't go and do the step of sorting as I should have. So how did you interpret this? Did you find that this made sense or that it did not make sense? Any ideas here? I mean, I think some teams thought that it did make sense. Other teams thought that it did not. Blair?
Well, I can tell you from my background, it makes sense. These triggers are clear signs of someone who would want to commit fraud. Low credit score, low income are going to be flags for someone who's going to want to commit fraud. And those are going to be flags that we're going to be looking for in a potential applicant for insurance.
Right, so you say that the data that we have makes sense based on your prior experience of low credit score, low income. So it seems to be consistent. So remember, that was one of the tests that we want to apply to the data, is that the results that we're getting is, do they make sense outside of just this data set of what we're getting? But what if they don't actually make sense? What if they are just what they are? They're giving us a model, but it's still effective to predict fraud. Can we use them even if we don't understand them, even if we can't make sense out of them or they seem counterintuitive to us? Or should we throw the whole thing out? Yes, Paul?
Well, you could have a counter strategy of if you know someone's suing you and you find out, okay, how much are they asking for and really how much of that resource are we going to mount up to make sure that we don't spend too much on these fraudulent claims.
Well, so you're talking about developing a counter strategy, but how would you use this data to help you develop the counter strategy? For example, to predict whether or not someone has actually committed fraud might influence your strategy, right?
Well, if there was that goal, there was goal lawyer or like teams, so that was, based on what we saw here, is if it's goal lawyer or lawyer teams that are assembling, and you know that his profile is of a low credit score, they just recently got this insurance policy that should bring you on for fraud, and how much you're going to then spend to that go against them.
Right, so you're saying you could actually take one of these rules and apply it in practice because this would give you something to look out for. One of the problems with that is if you had a model where you had 30 rules, 40 rules, 50 rules, it might be a little bit more difficult to figure out when to apply them, but you could still throw the latest data into the package and see what came out. Blair?
So one of the biggest expenses for an insurance company is the lawyer factor, and when someone lawyers up, our costs go increasingly up. And so that's one of the, obviously, things we see in here. And so that's something we can extrapolate, and the insurance company would be able to extrapolate on top of this. And take this, even if it didn't apply, we would be able to apply that in terms of our settlement and decide whether or not we want to just pay the claim and take what they want to, settle it now instead of going to court and maybe find out that it's fraud, but we paid $50,000 in court costs as opposed to paying their $5,000 now and avoid the $50,000, even though we found they're not guilty for it.
Right, so there's a lot of considerations going on in determining what you would actually do. So let me get to one of the central issues of this case, and that is whether or not the whole model that we're creating, if you include attorney in the model, do you have an actionable model for this? So because all of you got that attorney was one of the top things. Chris?
I didn't think you did, no, because on the flow chart, the decision point for the adjusters deciding whether or not to investigate is before the point where you would have information on the attorney in that situation.
Right, so that was one thing that I wanted you to see. So how many people got that including the attorney would actually make the model unusable? Okay, so you were the only one, so give yourself a pat on the back for that. I thought your team back there, Zach, you were getting towards that idea.
We questioned about attorney, but then when we looked at flow chart, it didn't make any sense.
I see, so it didn't make sense to you. So let's look at the flow chart one more time. The claim is filed with the claim amount. There's an adjudicator. The adjudicator has to decide whether to challenge. That's at the point where we need this model. So the model, if the model says people with credit score less than 345, then that might help the adjudicator. But if the model says with 345 and lawyer equals gold, well, we see later that the person lawyers out, the claimant decides whether to fight, may hire a lawyer only after the investigation has been made. So at that point, it's too late to use that piece of information in the analysis. So what happens in our model if we take that lawyer out? So if I go back to my fraud data and I say analyze fit model, sorry, that's not the right one. Analyze modeling, partition, recall, but now I'm going to take the lawyer out. Attorney goes out, attorney at all goes out, and that gives us just these things. I've got my same validation column, and I'm going to hit collect points, and I'm going to hit display options, show split count. I'm going to click go, and I get my R squared is only about 0.1 or 0.09, and I have just one factor in this model, credit score. So that was the only factor that JUMP could use to actually improve anything. When I show the fit detail here, though, I am still only misclassifying 10% of the records. So we can see what our test matrix looks like. You know, we had, for fraudulent cases, we had about 500, and we misclassified about 350 of them out of maybe 450. So our rate of misclassification on fraud was real bad. We missed a huge number of the fraud cases. We were able to pick some up on the basis of credit score, on the basis of every other factor we had in the model, nothing. So maybe this is going to be usable. Maybe it's just one rule of thumb based on credit score, and beyond that, we're going to have to do more research to come up with better factors or come up with a better model to be able to use this. So that's kind of what I wanted you to see. You know, you can go through the analysis, but make sure that what you're doing is consistent with the business process that you are trying to help to improve by deploying a model, because we're talking today about deployment. More questions or comments about this model, Blair?
Well, so is it just the model, or, because like the data that we have isn't showing it? Because lower income is an indicator of fraud, and what you're showing here isn't showing that.
Well, so the model, our model didn't find it. So does that mean that we only have how many records in this? 5,000 or 10,000? How many is it? Yeah, 20,000 records. I mean, so maybe this is a real small sample. Maybe I'm really not sure of the provenance of this data. It came through a data mining textbook to me and stuff like that. So is it all that realistic or something like that? So maybe we're not detecting that pattern. Yeah, right. At this point, doesn't necessarily mean it's not there.
Data criteria that we were using there, I would expect to see linking to fraud.
It may be that, as I say, our sample of data is not that good. For this insurance company, that's not true. So, any other comments or questions about this, Zach?
So I just had a general question. If it's way off topic, we don't even have to talk about it. But as we're going through some information and we're trying to find out what influences what, especially if we're implementing it in a real world situation, can't some of this get pretty discriminatory? So, like if you find that, well, a good example is male teenage drivers are more expensive than female. So, I guess I don't know exactly where I'm going with this, other than if we find that type of information, is it are we able to use it?
Yes, yes. So that is actually, there is a certain area of the law that says, the problem is that I don't understand it that well myself. I may have to defer to the lawyer in the room.
You're not allowed to make business decisions on the basis of a protected class. You can use things like gender. A lot of it has to do, like, if you deny coverage based on a protected class, you're going to be in trouble. If you deny employment or make employment decisions on the basis of class, you're going to be in trouble. If you're making decisions based on things like premium, you're in a grayer area.
Right. So we have, so insurance companies are one of the few industries where we can discriminate, and I use that word very liberally, and we can associate premium based upon your age, your gender, the driver. We can assign you a higher or lower premium based upon those characteristics, and that's technically discriminating, but there's the statistics to back it up that show those are higher or lower risks. So it's been gone through.
Yeah, I don't know the last time it was tested. It'd be interesting if it would come out differently now, whether the disproportionate impact, whether there's.
Yeah, that was the concept I was trying to think of, is that term, disproportionate impact. So that's the thing, is that you have to, so here I think Zach's question is extremely relevant because of the fact that, let's say we make a model today in February, or what are we, in March, sorry, 2016, and we keep using it for a year, but 1 year from now, it turns out that our model has cooked in discrimination. And in fact, if we used it for 2 years and nobody remembers why we had that in the model or where that those little rules crept in, and they're baked into our software, they're baked into what our agents are doing, everybody in the company says, hey, we don't discriminate. And nobody realizes that baked into the computer somewhere is a discriminatory rule of some sort. And it came because somebody did some data mining at some point in time that was valid for a period, but is no longer valid. So that just says that you have to update these models on a regular basis. You have to continually look for other signs of evidence that you are not discriminating, and you have to understand why you're making the decisions you're making. So extremely relevant because it applies to all of this data mining that we're doing, right? Because we are trying to figure out ways to discriminate, to use the original meaning of that word to distinguish one group from another group, not necessarily with any negative reasoning behind it, but only a positive reason for us as a business people that we want to make more money. So why should we offer our product at a cost to us, to customers, if we know they won't buy it, right? So that is, or we're pretty sure that they won't buy it. Are we required to sell to every single person on the face of the planet? So I think those are some of the lessons that we wanted to get out of that. I'm going to go ahead and open up the next PowerPoint here for session 3. Let's see, 3C for today. Okay, and so we're coming in this part. We are, what I have on this slide, understanding results of classification. I'm making a point that I made a little bit earlier in the class, and that is to say that when we use any of the techniques we use, if we're using regression trees, logistic regression, partitioning, even when we use fit Y by X or fit model, we are in a sense always doing classification. We're always coming up with an answer. For example, if we're doing fit Y or X, we're testing, do we have 2 different samples in our population? So in a sense, we're doing a form of classification. Right? So I want you to see, if you come back to this later, after you've studied the techniques a little bit more, you can see that we're really talking about the same thing in all these cases. We're always doing the same thing. We're always classifying. It's just we're using various different techniques in order to do it. Okay, so let's talk about this idea of misclassification costs a little bit more. So I showed you the example with the smoking cessation idea. So let's take one more example of that might be a little bit more relevant to us here. So let's say that we're sending out a promotional offer, and we're going to send it to 1,000 people, and we have a 1% response rate. That means to say that out of those 1,000 people, we're going to get 10 people who respond to the offer. So, yeah, one equals response. It should have said 0 equals non-response, but I don't know how that happened. But anyway, the naive rule would classify everybody as non-response. Right? Remember the naive rule? I should have asked you what it was before I called that up there. But anyway, the naive rule said that we classify according to the dominant class. So if we said that we're going to get a 1% response rate, how would we classify everybody? We would classify them as non-response. If we thought that nobody was going to respond to the offer, then what would we do? Right, we would never send the offer. So clearly, if we use the naive rule in a case like this, we wouldn't do anything for this. So now let's assume that we use data mining of some sort, any of the algorithms that we're talking about, and we find 8 responses. And so out of those, and those are correct, people who would respond. We find 8 people who respond, but we classify 20 people incorrectly. And we say, oh, those other 20 are also, we think they'll respond, but they didn't respond. And we miss 2 people who would have responded. So you'll recognize that that gives us a confusion matrix here. So we're going to look at that confusion matrix in a minute, but let's start off by saying what would happen if we predicted everybody as being non-response. We'd have the 1% error rate. So you can see how I'm setting up a confusion matrix like I did before here on this first screen, showing what would happen if we predicted everybody according to the naive rule. All right, any questions about what I just did through this screen? Okay, then, so that's the naive rule, right? Okay, so here's our rule, our matrix, if we did what I just said a second ago, which was, we said we've got, we predicted 28 people as response. Notice the column on the right is showing us how many we predicted because the x-axis is always the predicted, the y-axis is always the actual. And so if there's ever any doubt about that, make sure that you understand, that you orient yourself properly to which one is which. So this gives us a 2.2% misclassification rate. That's worse than a 1% misclassification rate. So does that mean that this model is worse than our naive model? No, it doesn't seem to be. So that's why I say that misclassification rate in and of itself is not going to tell us whether or not we have a model that's worthwhile. We have to look at other factors to determine whether or not it's worthwhile. Now, let's introduce some costs. So let's say that when we find someone who's going to respond, they buy our product, we make a total profit of $9. So we got $10 from them, but it costs us $1 to make the offer, so that the difference is $9. So when we predict someone who's going to be a non-responder, and they would have responded, then we lose a theoretical $9. Now, in this class, and sometimes I've called that a opportunity cost, but some people in the class who have corrected me to say that that's not truly an opportunity cost. So I'm not calling it that. I'll just call it missed revenue. I think we can agree that missed revenue is a term for that. And then the people who we got right as being non-responders, that's not costing us anything. So there's our cost matrix. Any questions about the idea, again, of the cost matrix? The reason I'm showing another example of this is when you get to your Charles River case that you have to do for the next assignment, there's one aspect of that case where you create a spreadsheet that has a cost matrix in it. So it goes through a number of different costs for the books that are being sold, the books that are being returned, and everything. And so one of the things that you need to do right at the beginning of the assignment is set up your spreadsheet so that you can plug the numbers in and find out what is the overall profitability depending on what the model is telling you about the number of responders that you're going to get out of that. So I'm going to multiply my confusion matrix times my profit matrix, and I'm going to find out that with the model that we fitted, we make a profit of $52 of this. Okay, so that's pretty good, but what if we went ahead, well, first of all, how did we get that? One more time. Why are we sending the offer to 28 people? Because we took the response, predicted a response column. So we didn't know which of those 28 were going to respond, right? We didn't know what the exact balance was going to be. So we had to send it to all of those 28. And then that's, again, showing you how that we got to 52 as the calculation. So any questions about how we got to that particular number? Okay, so now, now this is the old way. In the olden days, I used to send it to everybody, right? That was when I was very naive, when I thought, okay, if I send to everybody, I'll just get the responses I get, and whatever it costs me, I'm not going to pay that much attention to it. If I did that, then what would we do? We'd be predicting 990 people wrong, 10 people right. We'd get every single person right, but we would make that mistake with all the other people. That would cost us $900. So the best that we can do, though, if we predicted everyone perfectly, again, would be $90 because we have absolutely no errors for that. So I think, do I have a summary here of that? Right, the results summarized. So if we had the magic wand that we could wave and we could actually find all those people and make no mistakes, we'd get a total of $90. But if it's still going. If we use our data mining, we get $52, and that's a whole lot better than doing nothing. And a whole lot better than sending it to everybody. So I think this in a nutshell, I hope is summarizing for you why people are so excited about using analytics. Because this is such a typical example that we would use for sending offers to our customers. So any questions about what I just showed you here?